In the dead of a Chilean night, high atop a mountain where the stars burn like lanterns in an endless void, a telescope hummed quietly, its lens drinking in the light of distant worlds. It was July 1st, 2025, and the Atlas Observatory stood sentinel, scanning the heavens as it had countless times before. Then a flicker, a faint, fleeting dot just beyond Jupiter's orbit, moving too fast, too strangely to be ignored. At first, the astronomers thought it was just another wanderer, a chunk of rock or ice tumbling through the solar system's familiar lanes. But as the hours ticked by, their screens lit up with data that sent a shiver through the room. This was no ordinary comet. This was something from beyond, far beyond. Named Comet 3, I/ATLAS. It was a traveler from the uncharted abyss between stars, only the third interstellar object ever to grace our skies. And in the days that followed, it ignited a fire of wonder and curiosity that swept across the globe, whispering questions we've barely dared to ask. Where did it come from? What secrets does it carry? And could it finally unravel the mysteries left by its strange predecessors? The discovery felt like a moment torn from a dream. Picture it. A team of stargazers, bleary-eyed from hours at their consoles, suddenly jolted awake by an anomaly. That tiny dot wasn't just moving, it was racing, hurtling through space at 70 kilometers per second, a speed so ferocious it laughed at the sun's gravitational leash. Most comets in our solar system dance in tidy elliptical orbits, tethered to the sun like kites on a string. But 3I/ATLAS. It was a runaway, its path a hyperbolic slash across the sky, unbound and untamed. To the astronomers, this was the first clue, a mathematical fingerprint of an outsider. Orbital eccentricity, the measure of a path's deviation from a perfect circle, told the tale. A circle is zero, an ellipse lingers between 0 and 1, and a parabola, the edge of escape, sits at 1. Anything above? That's the mark of an interstellar vagabond. With an eccentricity soaring past 6, 3I/ATLAS declared itself a stranger, a cosmic nomad passing through our neighborhood on a one-way ticket to eternity. But what was it, this fleeting visitor? Not just a barren rock, it turned out, but a comet, a glowing, icy relic that whispered of ancient origins. As it drew closer to the sun, its frozen heart began to stir. Sunlight kissed its surface, in volatile ices, locked away for eons, sublimated into gas, unfurling a faint, fuzzy halo around it. A coma, they called it, the ghostly shroud of a comet awakening. Soon, a stubby tail flickered into view, a trail of dust and gas stretching like a comet's signature scrawled across the void. Over 100 telescopes worldwide turned their gaze to confirm it, their images painting a picture of a comet coming alive, shedding its ancient skin as it neared the warmth of our star. The International Astronomical Union, the gatekeepers of cosmic nomenclature, christened it C/2025N1, a name that carried its story. The C marked it as a non-periodic comet, a wanderer never to return. 2025 pinned it to the year of its discovery, and N1, a nod to the first half of July, the moment it burst into our awareness, the first of its kind to light up that fleeting window of time. The comet's brightness was another clue, a beacon of its restless nature. Though dim, 2.5 million times fainter than the steadfast pole star, it glowed with the promise of activity. Dust, kicked up by its outgassing, caught the sun's light, making it shimmer like a distant lantern. Scientists estimated its size somewhere between 5 and 50 kilometers across, potentially the largest interstellar object we've ever glimpsed. At the moment of discovery, it was 670 million kilometers from Earth, lurking near Jupiter's orbit, a silent giant gliding through the dark. Its journey, they calculated, would bring it to perihelion, its closest brush with the sun, on October 30th, 2025, dipping just inside Mars' orbit at 206 million kilometers. But there was a catch. During this climax, it would hide on the sun's far side, veiled from our eyes. Only in early December would it emerge, offering a brief encore before fading into the cosmic night. visible to our mightiest telescopes until early 2026, when it would slip back into the interstellar deeps, perhaps never to be seen again. This comet wasn't just a spectacle, it was a messenger, carrying echoes of a universe we're only beginning to understand. Its arrival stirred memories of the two interstellar pioneers that came before. Oumuamua and Borisov, each a riddle wrapped in starlight. Oumuamua, spotted in 2017, was the first to challenge our assumptions. It, too, screamed through the solar system on a hyperbolic path, but its behavior was anything but ordinary. After swinging past the sun, it sped up, not by much, but enough to raise eyebrows. This non-gravitational acceleration hinted at outgassing, the kind comets produce when ices vaporize into jets. Yet Oumuamua was stubbornly silent. No coma, no tail, no trace of anything familiar. Its shape, inferred from its flickering brightness, was even stranger. Either a cigar-like sliver or a pancake-flat disk, unlike anything born in our solar system. Theories swirled. Could it be laced with exotic ices, hydrogen or something else, that vanished without a trace? Or, in a fleeting moment of wild speculation, was it something artificial, a derelict light sail from a civilization long gone? The alien hypothesis captivated the world, though science gently steered us back to nature's handiwork. Still, Oumuamua's origins remain a tantalizing blank, a question mark etched in the stars. Then came 2I/Borisov in 2019, a comet that felt like a sigh of relief. Discovered by an amateur astronomer with a backyard telescope, it was everything Oumuamua wasn't. A wasn't a classic comet, draped in a bright nebula-like coma and trailing a long, ghostly shroud. Its carbon-based presence gleamed proof familiarly, reassuringly proof, as if it too were saying, "This is what you expected, isn't it?" "I'm what astronomers expected, Borisov." Borisov confirmed that interstellar comets could mirror our own, proving that our solar system, wasn't alone in sculpting icy wanderers capable of surviving the long, perilous, lonely trek between stars. Together, these two painted a paradox. One alien in every sense, the other a glimpse comfortingly of familiar. And now 3I/ATLAS steps this into Comet, the cosmic drama. Spotlight, a third piece frozen in a puzzle we're only just beginning to piece assemble. As it races toward Comet's the cousin sun, to embrace its or promises does answers. Or it perhaps lean toward the enigmatic defiance? As it drifts toward answers, it holds the spark promise of new questions that will burn forever, or new mysteries that might haunt us for generations. The arrival of Comet 3I/Atlas feels like a cosmic gift, a fleeting chance to peer into the unknown. Imagine standing beneath a star-strewn sky, knowing that somewhere out there, a fragment of another world is racing through our solar system, carrying secrets older than the Earth itself. This isn't just a comet, it's a time capsule, forged in the fires of a distant star, ejected into the void by forces we can only guess at. Its icy surface, scarred by eons of cosmic radiation, holds clues to the chemistry of alien worlds. As it sweeps closer to the sun, each puff of gas and dust it releases is a whisper from a place we'll never visit, a story written in molecules that might tell us how planets are born or how they die. The weight of that thought is staggering. This comet, this solitary wanderer, could be the key to understanding whether our solar system is a fluke or part of a grand galactic tapestry. And yet, its visit is brief, a mere blink in the cosmic clock, urging astronomers to act fast before it slips away forever. What makes 3I/ATLAS so tantalizing is its timing. We're not the same species that spotted Oumuamua or Borisov. Our tools have grown sharper, our eyes keener. Telescopes across the globe, from the peaks of Chile to the deserts of Australia, are trained on this comet, their mirrors drinking in every photon it scatters. Satellites and space-based observatories, unhindered by Earth's atmosphere, are joining the hunt, capturing spectra that reveal the comet's chemical soul. Is it laced with water ice, like our own comets? Or does it carry stranger ices, methane, ammonia, or even frozen gases we've never seen in our cosmic backyard. Each observation is a puzzle piece, and with every passing day, the picture grows clearer. By comparing its composition to Borisov's familiar carbon-based ices or Oumuamua's elusive makeup, we might finally learn whether planetary systems across the galaxy churn out similar recipes, or if each star crafts its worlds with a unique signature. The stakes couldn't be higher. This comet could show us that the building blocks of life, the organic molecules that sparked our own existence, are scattered across the cosmos. But 3I/ATLAS is more than a chemical archive. It's a survivor. To reach us, it endured a journey through the interstellar void, a realm so vast and empty it defies comprehension. Picture it drifting for millions, perhaps billions of years, alone in the dark, bombarded by cosmic rays and micrometeorites. What could fling such an object into the abyss? Maybe it was born in the chaotic nursery of a young star system, where gravitational tugs from forming planets sent it careening into exile. Or perhaps it was torn from the icy fringes of a dying star, a relic of a system that no longer exists. Every scar on its surface, every molecule it carries, is a clue to that violent birth. And as it approaches the sun, it's changing, shedding layers like a traveler shedding a heavy coat. The coma and tail, glowing faintly in our telescopes, are signs of that transformation, but they also hint at something deeper. If 3I/ATLAS starts to behave strangely, say accelerating without explanation like Oumuamua did, it could mean we've been wrong about what interstellar objects are supposed to be. Could it harbor exotic ices that vaporize invisibly? Or is there something else at play, something we haven't even imagined? The ghost of Oumuamua looms large here. That strange, silent visitor left us with more questions than answers. Its acceleration, subtle but undeniable, suggested outgassing, yet it refused to show the coma or tail we'd expect. Its shape, possibly a thin, elongated shard or a flattened disk, defied every model of natural objects we know. For a moment, the world dared to dream. Could it be a probe, a relic of some intelligence probing the stars? The idea was intoxicating, even if science quickly grounded it. Most astronomers now believe Oumuamua was natural, perhaps a fragment of a shattered world. Its ice is so exotic they left no trace we could see. But the doubt lingers, a quiet hum in the back of our minds. 3I/Atlas, with its visible coma and tail, feels like a chance to settle the score. If it behaves like a normal comet, it might suggest Oumuamua was the oddity, a cosmic fluke, a one in a billion quirk. But if it starts to mimic Oumuamua's strangeness, if it defies our predictions as it nears the sun, it could mean that interstellar objects are far weirder than we've dared to believe. The tension is palpable. Every new image, every data point could rewrite the story of our place in the universe. And then there's Borisov, the comet that felt like home. When it sailed through in 2019, it was a revelation in its simplicity. Its bright coma, its streaming tail, its familiar ices. It was as if our solar system had sent a postcard to itself, saying, "See? We're not so special." Borisov showed that comets like ours can survive the long journey between stars, that the processes shaping our worlds might echo across the galaxy. But it also raised a question. Why was it so different from Oumuamua? Was Borisov the norm and Oumuamua the outlier? Or do interstellar objects come in a dizzying array of forms, each shaped by the unique story of its home star? 3I/ATLAS is our third clue, a tiebreaker in this cosmic mystery. As it nears perihelion, astronomers are watching for signs of its personality. Will it blaze brightly, like Borisov, or hold its secrets close, like Oumuamua? Every flicker of its light, every shift in its trajectory is a chance to learn whether our solar system is a common thread in the galactic fabric, or a singular fleeting stitch. This moment feels like the cusp of something bigger. We're not just chasing a comet, we're chasing the story of creation itself. 3I/ATLAS is a bridge between our world and the infinite unknown, a reminder that the universe is vast, restless, and full of surprises. As it races toward its closest approach to the sun, hidden for a time behind our star's glare, astronomers are holding their breath. When it reemerges in December, it will offer a final glimpse, a last chance to capture its essence before it fades into the void. And even then, it won't be the end. The data we gather now, the spectra and images and measurements, will fuel decades of study, each analysis peeling back another layer of the comet's story. This is more than a fleeting visitor. It's a spark that could ignite our understanding of the cosmos, a fleeting chance to touch the infinite. As Comet 3I/ATLAS streaks through our solar system, it feels like we're standing at the edge of a great unknown, watching a messenger from the stars deliver its fleeting sermon. This is no ordinary visitor. It's a relic of creation, a shard of ice and dust that has wandered the galaxy for longer than humanity has dreamed. Its journey is a reminder of how small we are, yet how vast our curiosity can reach. In the coming months, as it swings around the sun and briefly vanishes in its glare, the world's astronomers will wait, hearts pounding, for its reappearance. When it emerges in December 2025, it will be our last chance to steal a glimpse of its secrets before it fades into the cosmic dark. But even as it slips away, it leaves behind a legacy, a spark that could light the way to a new era of discovery. This comet is not just a spectacle, it's a turning point, a moment when we realize the universe is ready to share more of its story, if only we're bold enough to listen. The tools we wield today are nothing short of miraculous, a testament to our relentless hunger to know the cosmos. The Vera C. Rubin Observatory, rising like a titan in the Chilean mountains, is the key to this new chapter. Its 3.2 gigapixel camera, the largest ever built, is a marvel that can swallow the entire night sky in a single glance, scanning it every few days for fleeting visitors like 3I/ATLAS. During its first look event, Rubin proved its might, spotting over 2,100 new asteroids in mere hours. When it's fully operational, it will rewrite the rules of discovery, catching comets and interstellar objects at a pace we've never seen. No longer will we wait years, even decades, for another interstellar guest. Rubin promises a future where these cosmic wanderers become familiar faces, arriving not once in a lifetime, but perhaps every year. Each one will add a new thread to the tapestry of our understanding, helping us map the unseen corners of the galaxy. With 3I/ATLAS, we stand on the brink of that future. Its arrival is a gift, but also a challenge. With only 3 interstellar objects ever confirmed, Oumuamua, Borisov, and now this, we're working with a mere handful of clues, like trying to solve a puzzle with half the pieces missing. Each object is a snapshot, a single note in a symphony we can't yet hear. But as Rubin and other observatories come online, we'll gather more, dozens, perhaps hundreds of interstellar visitors in the decades to come. With each one, we'll learn to categorize them. Are most like Borisov, with their familiar cometary glow? Or do they echo Oumuamua's cryptic silence? 3I/ATLAS is our third data point, a crucial step toward answering that question. Its icy nature, its faint coma and tail, suggest it leans toward Borisov's camp. But as it nears the sun, anything is possible. A strange acceleration, an unexpected chemical signature, could tip the scales, hinting that Oumuamua wasn't the outlier we thought. The more we learn, the more we'll understand how stars forge their worlds, and how those worlds, like ours, are sometimes cast into the void. This comet also carries a deeper promise, a chance to trace the origins of life itself. The ices locked within 3I/ATLAS, forged in the crucible of another star, might hold the same organic molecules that seeded Earth's oceans billions of years ago. If its chemistry matches our own comets, it could mean that the building blocks of life are universal, sprinkled across the galaxy like cosmic pollen. If it's different, it might reveal that each star system has its own recipe, its own unique flavor of creation. Either way, the implications are profound. As we study its spectra, parsing the light it scatters, we're not just learning about a comet, we're probing the very processes that make planets habitable. This is why 3I/ATLAS feels so urgent, so alive with possibility. It's not just a rock and ice hurtling through space. It's a mirror reflecting our own origins. A reminder that the universe might be teeming with the potential for life. Yet there's a bittersweet edge to this story. 3I/ATLAS will soon be gone, its light dimming as it races back to the interstellar void. By early 2026, even our mightiest telescopes will struggle to see it, and it will vanish, perhaps forever, into the vastness from which it came. But its departure isn't the end, it's a beginning. The data we collect now will live on, fueling research for generations. Scientists will pore over its chemical fingerprints, its trajectory, its behavior, piecing together the story of its birth and its journey. And as new telescopes like Rubin light up the skies, we'll be ready for the next visitor, and the one after that. Each will bring us closer to understanding the galaxy's architecture, how stars form, how planets coalesce, how comets are flung into the dark. 3I/ATLAS is a herald, a sign that we're entering an age where the universe's secrets are no longer out of reach. As we stand beneath the stars watching this comet blaze its trail, it's hard not to feel a sense of awe. We are witnesses to something ancient, something that has seen worlds we'll never know. It reminds us that the universe is not a static place, but a restless, churning expanse, full of stories waiting to be told. 3I/ATLAS is one of those stories, a fleeting, luminous chapter that has captured our imagination and refused to let go. It asks us to look up, to wonder, to chase the unknown with every tool and every ounce of courage we have. And as it fades, it leaves us with a challenge: to keep searching, to keep questioning, to never stop reaching for the stars. Because somewhere out there, another comet is already on its way, carrying the next piece of the cosmic puzzle, waiting for us to find it.